Hi, hi everyone. Let's discuss Leetcode problem 23, merge K sorted list. And let's see what the description is. The description says that you are given an array of K linked lists. Each linked list is sorted in ascending order, and you want to merge all the linked lists into one sorted linked list and return it. So let's try to see the example. So this is the input list, and we see that it is comprised of three sorted lists as we can see them. And what we want is an output that is completely sorted, and it is an outcome of merging all these above lists together in a sorted fashion. So, the first thing that should come to your mind is that we want a sorted output. And the easiest thing that we can think of is that iterate on each element, put it on to the priority queue, and then once we have added all the elements into the priority queue, we can just pull the elements one by one and just add them into a sorted list output. And that's it. And that will work. So I think in that scenario, the complexity of the problem is um, let's assume that the total number of element is n. Then what we have done in that scenario is that we have created a priority queue of size n. And so the insertion at every time when we are inserting is having the complexity of n, log n, sorry. And then what we are doing is that we are doing it for the complete n number of times. So that means that the complexity of adding all those elements into an n size priority queue will be n log n. So that is the complexity when you are creating the priority queue. And then when you are pulling each element to create a linked list, it's the same. So pretty much 2n log n. And you can say O n log n is the complexity of the solution, where n is the complete number of elements under consideration. And I think that works, but I think we can do much better in that scene. So let's see what we can do better about it. So on the right side is the working solution. And the idea is that you have this priority queue and only insert the first element of the linked lists that you are given with. So suppose we are having K linked lists. So we will insert all the first elements of each list that we have. So at this point, the size of your priority queue is K, where K is the number of the linked lists in the input. So suppose in the example, we have three linked lists. That means the size of the priority queue is pretty much 3 here. Okay, so what we can do then is just iterate over the priority queue one by one, pull the element, and this is the minimum element that you have on the priority queue. Now add this element that you have popped into the final output list because it's the minimum element that you can get. And if you have get it, what you can do is just add the next element that is the next element of the popped element, and that's it. So have the K size priority queue list, start popping the element. When you pop it, you add it to the output. And then if you have a non-null output, you just find the next element of the popped element and add it to the priority queue. And in the scenario, if you don't have, suppose that's the last element that you popped out, you won't have the next element. So you just bypass it, just add that element to your final sorted listlet, and then move on and try to find what is the minimum element that you can pop it out and just follow the rest. And that's it. So let's see how it performs. Let's try to submit it. And yeah, it works fairly well, like with 75% of the people. And that's it. Yeah. Thank you.